go. Oh, Kaylee says, yeah, what about the count from Sesame Street? Great point. He's obviously good at math. All right, so you've seen this before. We did this the other day. And I just want to run through these terms again so they're totally fresh in our minds. Our first one is a relation, so that's any relationship between two variables. A function is a specific kind, where for each element in the domain, those are our x values, it's only got one element in the range. Those are y values. So that's the kind of like chunky, clunky, I should say, definition for a function. And we said, okay, let's remind ourselves what domain is. Domain is all the x coordinates, all the x values that our function could have. And so we're thinking about the horizontal axis, and we also call that our independent variable. Right? So that's the one we're usually changing on purpose when we're doing some type of science experiment or something like that. Our range is all our y coordinates, all our possible y values for our function. We're looking at the vertical axis to know what it would be, and we call that our dependent variable. That's the one we're measuring when we're doing science to try and figure out what changed. Set notation is just a way of writing things in curly brackets. So if you've got a laptop with a keyboard, I'd like you just to right now have a look and see if you can find where the curly brackets are on there. You usually will have them on the same button as the square brackets because that can be handy to know where those are. Okay, so curly brackets, the stuff inside there, that's going to be called our set notation, and that's going to tell us like everything inside those curly brackets. That tells us the possible values that we could have for our domain and for our range, our possible x values and our possible y values. If we go to Desmos for a second, I know you can't see everything that's on the screen there, but I'm going to make a little function here. I'm going to say f at x equals, let's do x squared. That's just our basic quadratic, and there it is on the screen, okay? So I've done my f of x equals x squared, or y equals x squared. I guess you could say that's our basic quadratic. Now I can have a look at this and I can say, can I plug in any x value for this? And the answer is yeah, I can plug in any x value for this. One second, I'm just going to move my screen over a little bit here so you can see what I'm doing. All right. So here's my quadratic, and I put in a table of values, right? And so those spots appear as like dots on my quadratic. So I say, okay, I've got some different x values that I could have. I could input -2 as an x value, or -1, or 0, or 1, or 2. Those are all things I could input. But could I put in, say, 100 into this function and get a y value? And I can, and there's only one answer. I could put in 100, or I could put in -100. Both of those would work. Could I put in 1,000? The answer is yeah, I can put in 1,000. Can I put in -1,000? And the answer is yeah, I can put in -1,000. Can I put in like 10 million? And the answer is yeah, I can put in 10 million. So I can put in any x value I want, positive or negative, and it'll be on this graph somewhere. If you zoomed out enough, it would be on there somewhere. But you'll notice my y values in that table where it says f of x, my y values, they're always positive. There's no y value that's going to end up being negative, right? Because there's no part of the graph that's below the x-axis. There's no negative y values. You can't actually put in any input, any x value that will give you a negative y value. You can't do it. So for my x values, I can have any x value because this quadratic, this parabola is going to keep going out and out and out and out and out and out and out to each side. But it will never have negative y values ever. Of course, I could have any positive y value. Okay, so that's what we're kind of thinking about when we're trying to describe domain and range. Let's go back to our thing here. So I'm going to talk you through some of these, and then we'll start being ready to write our domain and our range. And there's kind of like a very specific way you do it. So again, our domain is the set of all possible x values. That's our independent variable. Our range is the set of all possible y values. That's our dependent variable. So what we're going to do in the first couple examples is I'm going to actually write out the range and the domain. And we're going to start with these two examples here. The first one is when we've got these kind of like bubbles showing our relations. The next one is a very similar one, but it's showing things as a set of ordered pairs that we could put on a graph. So we're going to try and write the range, or the domain and the range. So I'm going to start with the domain, all my possible x values. I'm going to start by writing a capital D for domain, and then I'll put an equals sign. And then I need to put my like curly bracket to start this. And that's going to show, and my curly brackets are not going to be the best, and yours probably won't be either, and that's okay. Just do something that's as good as you can to draw a curly bracket. Now inside here, I'm going to list all my possible x values, all the ones that are right here. So I'm going to list -3, I'm going to list -1, and I'm going to put a comma in between each of them. 1, 3, and 5. Those are all the possible x values I can have. And I'll end it with a little curly bracket. For my range, let's switch colors here. My range is all of my y values. So I'll put a capital R for range. And what y values can I have? Let's start with a curly bracket. And I can see them all right here. And I'll write them in: -2, 0, 2, and 10. Those are all my possible y values. Now the thing about writing the domain and the range is we can't see the relationship that one has to the other, and that's fine. You're not supposed to be able to. We're just basically saying what are the possible x values we could have, what are the possible y values we could have. So now I'm done my domain and range. Started with the capital letter, D or R for domain or range, put everything inside the curly brackets, and separate them by commas. Now I can do the same thing for my next set here. So for my next set, I'm going to start with my domain. So I'll put a capital D for domain, I'll put an equal sign, I'll put a curly bracket. Now I'm going to write out all the parts of my domain. Let's see what I got. I see I've got a 2, a -2, a -1, a 4, and a 0. So I'm just going to write all these in: 2, -2, -1, 4, and 0. Now, these aren't currently written in order. Could you write them in order? Yes. And it's totally fine to write them in a different order than you found them. And so writing them in order is totally a good thing to do. So I could say, okay, let's write, but it doesn't make it any more correct necessarily. Let's write them in order just because that's kind of a nicer way to do it. 0, 2, and 4. Okay, both of those are correct. The bottom one is a little easier to work with. Now let's do our range. For range, we're looking for our possible y values right here, right here, right here, right here, and right here. Now you're already maybe noticing something. There's a duplicate. 2 is listed twice, and that's fine. But we're only going to write it once in our range because we know it's a possible y value. We don't need to write it multiple times. So I'm actually going to write these in order. I'll just write 2, and then 3. Oh, 3 is listed as well. It's twice, isn't it? 2, and then 3, and then 5. And close my curly brackets. That's it. That's my range. Even though some of them appear multiple times, we don't write them again because we're just writing the possible y values that you could have. Okay, so that's our domain and that's our range for these two types of things. Okay, for these mapping diagrams and for our list of ordered pairs. Now let's have a look at a graph where we've got points on the graph and see how we would handle that. So when we're looking at a graph, we first want to figure out are we looking at individual points on the graph, which is the case here? If you look at the graph on the bottom, it's just individual points. Or are we looking at connected lines? Okay, because that's actually going to make a pretty big difference in terms of how we write it. So if we're looking at individual points, we're looking at individual discrete numbers. So they probably are integers like 1, 2, -5, -7, 15, whatever. If it's connected lines, we're using something called real numbers. Now, I don't imagine any of you have learned about imaginary numbers. And you will learn about that later. That's when you try and take the square root of -1. You'll find your calculator can't do it. And there's this group of numbers called imaginary numbers that you can do some funky things with. A lot of it comes up with electrical engineering and stuff like that when you're working with electricity. But for our purposes, we're just going to work with things called real numbers, which are any positive or negative numbers or 0, and anything in between. So 1 is a real number, 1.2 is a real number, 1.237 is a real number, 1,000,000 is a real number, -1,000,000 is a real number, -1,3/4 is a real number. And so when we're talking about real numbers, we're going to use this symbol that looks like this. It's kind of a double-lined R, okay? And that's going to stand for real numbers. So whenever you see that symbol, what we're hearing is real numbers. And that just means, like, could be anything, right? It could be anything. When you think about the numbers 2 and 3, there are infinite numbers in between them. There's 2.1, there's 2.11, there's 2.111, and you can go on forever. There's infinite numbers in between them. So all those are real numbers. Cassie asked, why do you have the domain written twice for B? I think you were talking about the previous one. And Cassie, the reason I did that was because I wanted to put the numbers in order. So I didn't actually change anything. I just changed it so the numbers were in order because it's a little nicer to have them in order. So great question. That's why I wrote that twice. Okay, if the graph is just made up of points, then all you have to do is list all the points, the x coordinates and the y coordinates. So let's do our domain and range for this one here. I'm going to start with my domain, and so I'm going to need all my x values. So I'll say, okay, my domain is equal to curly bracket, and now let's write them all down. Let's start with the one that's the lowest number. That would be on the far left. It looks like it's this one right here. And it looks like the x coordinate of that is -3. That's the x coordinate of that. So that one is -3. My next one along right here is at x coordinate -2. And then I've got one right here, x coordinate -1. And then I've got one right here, x coordinate of 0. I've got an x coordinate of 1, of 2, and of 3. So all of those x coordinates appear in the points on my graph. Range, I'm going to do kind of the same thing. I'll start at the bottom and look for the lowest one. In purple, it's right here. So that's a y coordinate of -2. I've got a point right here of a y coordinate of -1. I've got a y coordinate of 0. I've got two of them with a y coordinate of 1. I'll only write it once. And then I've got a y coordinate of 2 and a y coordinate of 4. So those are all the possible y values you could have in the points on the graph of this function. Okay, so far not so bad, right? We need to look at the x values and y values, or we need to look at a graph and look at the points and figure out what the x and y values are by kind of reading them off the graph. Now what happens if we just have a graph that's got some lines on it? Well, that's our next step. Let's put a screen on that so we can go slow. So if a graph is made up of lines, which is really common, we can't just list all the values, right? Because there's no single one value. You'd be going on forever. You can't list all the values. So in this case, we have to use a thing called set notation. So here's an example of how that would look. Now we say X, and then there's this like weird E symbol, and then there's an R. I'm going to tell you what this translates to in terms of math speak. Here's what we say. We say X is an element of real numbers. So that's how you say it in math speak. The X stands for X, that little like weird capital E looking thing that's curved stands for is an element of, and then the R stands for real numbers. Now really that R should have the like double line. That's how I'll write it when I write it up by hand, but sometimes it's a little, there is a way to get the text for that on the computer, but it's a little tricky. So we say X is an element of real numbers. That just means it could be anything. It could be anything. It could be 2. It could be 2.1. It could be 2.15. It could be 2.7. It could be 2.73. It could be anything. So X is an element of real numbers. Okay, and then we've got this like equality, inequality stuff right here that I've circled in green. And so on either side of that, we're going to put the boundaries of what X could be. So that might seem a little confusing. I'll show you an example so we can make this make a little more sense. So let's do just one at a time. Let's have a look at this one. It says state the domain and the range. Now something to keep in mind is that the ends here don't have arrows on them, right? That means it doesn't keep going on forever. It actually stops at either end. So that's good to know. It's also got solid circles, which means that the very end point is included. If it had an empty circle, that would mean that it gets right up to that point but doesn't quite get there. So that means that this is included. So let's see what our coordinates are of those endpoints. If I look on my graph, it looks like this is going to be -1, -2, -3, -4. Looks like this is -4 X value and 1, 2, 3, 4 Y value. How about this one down here? This one is -1 X value and 1, 2, 3, 4. Oh, sorry, I got that mixed up. It's -1 or -4 X value. Pardon me, and -1 Y value. There we go. Okay, I got it. So those are the endpoints there. And I want to include the endpoints. So if I'm going to write my domain, I'm writing all the possible X values in between the two ends of this thing. So what I'm going to do is I'm going to start by saying X is an element of real numbers. And what that means is that it could be anything in between these two spots. So in between, oh, sorry, I still got this wrong. That's a +4. What am I doing? That's a +4. I'm sure some of you noticed that, and if you did, I'm glad that you did. There we go. That's better. Okay. So in between -4 and +4 as our X values, there's infinite numbers squished in there. So we're going to say X is an element of real numbers, meaning it could be anything in between there. And then I'm going to put this line, and this line means such that. Such that. I'm going to add that up here so we have it for our notes later. So that line means such that. So X is an element of real numbers, but it can't be all of them. There's some limits there. So we're going to say, okay, what's it in between? It's in between -4 and +4. And so negative 4 is going to be always less than or equal to our x value, and our x value is always going to be less than or equal to positive 4. Then I put my curly brackets. So the way I've written this weird looking thing, when other people see that, they say, aha, this is what this tells me. My x values could be anything as long as it is negative 4 or positive 4 or anything in between. Let's do our range, our y values. Our range is going to be, again, we're going to say y is an element of real numbers, meaning it could be anything in between the possible ends, such that, well, where does y, what's the lowest number? Negative 1. And what's the highest number for our y? 4. So y has got to be in between these. So negative 1 is less than or equal to y, and y is less than or equal to 4. End it with my curly bracket. So this tells me I can have any y value, any one I want, as long as it is in between and inclusive of negative 1 and 4. Any y value in there is part of my function. Okay, let's try another one. Here we go. So this one does have arrows. They're headed downwards, meaning it's going to keep going like this either direction. Yeah, Marcia, you wrote, it looks like I'm writing ancient math runes. You're totally right. So this is getting into the language of math. And when people are working with math at a pretty high level, it does write like its own weird language. And so we are getting used to that. And once you've done it for a while, you get pretty comfortable with it. But in the beginning, it just looks completely weird and does take a lot of getting used to. So this point up here at the top of this peak is probably important. What's that? That's an x value of 0 and a y value of 1, 2, 3, 0, 3. So that's as high as my graph can go. The highest it can be is a y value of 3. And it could be anything under that. My x value, of course, could be anything negative or anything positive because these keep going on and on and on and on and on forever. So for my domain, it's actually going to be pretty easy to write my domain. I'm going to say my domain could be anything. X is an element of real numbers, meaning my x value could be anything. Any real number. For my y values, it's kind of similar. My y values, my range, I'll say y is an element of real numbers, meaning it could be anything, but there's a restriction, such that y is less than or equal to 3. Because it can't be bigger than 3. Otherwise, it would be somewhere up here, which is not on our graph. Our graph doesn't go there. Our function doesn't go there. So this tells us where our graph can be. It doesn't tell us the shape of it, but it does tell us where it can go. It has to be, our y values have to be 3 or less than or equal to 3. Okay, let's try a few more shapes here. Here's some funky shapes. Let's kind of limit our views so we're not doing too many at once. Okay, so for these, I want to kind of do a little bit of I show you one, then you show me one. So you can kind of like get the practice of thinking through it. For my x values, I look at this and I see, okay, I can't have anything over here because the graph doesn't go that way. So it looks like the lowest x value it can have is -3, because that's where this one ends. -3, +3. That's where that point is. So it looks like my x values have to be bigger than -3. It also looks like my y values have to be smaller than +3 because there's nothing above +3. So let's try writing these down. I'll start with my domain. My domain, Again, this is a line, so I have to say x is an element of real numbers. And if it's not points or like ordered pairs listed, we have to write that part. That just means it's a line, and I could have like any numbers anywhere along that line. So x is an element of real numbers, meaning it's a line, in this case a curved line, such that x is greater than or equal to -3. So as long as x is greater than or equal to -3, I could have that x value. I'd like you to try the range right now. On your notepad, try writing that down. What would the range look like? Fill out as much of it as you can. All right. Let's see how we did. So for your range, and any amount you're able to do is good, right? We all got to start from somewhere. So first thing we'd say is y is an element of real numbers, and we're just saying that because it's a line. So y could be any, we could pick any little number in there along that line, such that y is less than or equal to 3. So that's our range. We're saying you can have any y value as long as it's 3 or less. Aha, thanks Haley for letting me know I was muted. I was just saying you can have any y value as long as it's 3 or less. Right? We know we can have any y value as long as it's 3 or less. Okay, let's do our next one. Our x values. Now this one keeps going in this direction like that, and this one keeps going in that direction like that. And if they go far enough, really I could put in any x value. So it looks like this one to me, I could choose any value for x, because as long as I follow my graph far enough, I would get there. So that's an easy one to do. My domain, I say, is x is an element of real numbers. Go ahead and try the range right now. Can you folks give me a wave if you can hear me? I just want to make sure my mic is working. Okay, thanks. Okay, so for our range, same thing. But this time it's y is an element of real numbers, meaning y could be anything. Because we keep going down and we keep going up, we could have any value for y. So those ones are easy to write. And in fact, for anything that is just a straight line, as long as it's not straight horizontal or straight vertical, that's what it's going to be. Domain could be anything, range could be anything. So those ones are easy to write. Let's try these ones. Got some weird looking shapes. Our first one, we know it's going to keep going on like that forever, and this one's going to keep going on like that forever, and it's going to keep getting wider and wider and wider. So we can say, okay, for our domain, it could be anything. So x is going to be an element of real numbers. Could be anything. Let's try the range. Go for it right now. Try writing down what you think the range might be. Do as much as you can. Okay, for our range, first thing I want to see is that you're using curly brackets and you're saying y is an element of real numbers. You did all that? You're halfway there. Great. Now I'll say such that, well, it looks to me like our y values can't be down here. Looks like our lowest point is -1, -2, -3. This point right at the bottom of this W shape is as low as it can get. So y has got to be greater than or equal to -3. Anything above -3 is good. It can't be anything less. Last one here, let's try. It's kind of a circle, but looks like it's actually an oval. Because if you see the ends here, this end is at 4, 0. This end here is at -4, 0. Sorry, my 4s always look like 9s. The top here is 0, 3, and the bottom here is 0, -3. So it's actually a little bit more stretched on the sides. So it's an oval, not a circle. So we'll say, okay, our domain is the x values we could have. As you move around the circle, you could choose any x value you want as long as it's in between -4 and +4. So we're going to say -4 is less than or equal to x is less than or equal to +4. We'll put our close bracket on that. I'd like you to try the range right now. Go for it. Okay, our range, let's see how much you got. We would have said R for range. We would have said it can be anything, any number you want. So it's an element of real numbers. That's not my best writing. Such that there's some limits, right? -3 is as low as it can go. +3 is as high as it can go. So that's going to be my range. There's only one more section I want to show you, and that's when we've got an equation. We're given an equation. Now we're going to put Desmos to work. We know we had our parent functions yesterday. You had parent functions like a straight line, f of x equals x. You had a quadratic, f of x equals x squared. You had the square root. You had the reciprocal, right? These are our parent functions. What if we take one of our parent functions that's been transformed a bit? So let's have a look here. And when we're looking at range and domain, if we have an equation, we're going to need to know what it looks like. So here's just a hint first. Linear equations, anything that's a linear equation, meaning the biggest exponent on the x value is 1, it's going to have both a domain and a range that are just x is an element of real numbers, y is an element of real numbers. Done. Because those lines will go on forever. If we go to Desmos for a moment, we get rid of this. If we just put in a line, I'll say f of x equals, I don't know, let's pick a line here, 3x minus 2. Okay, so there's my line. This line will keep going on and on and on forever, and you could have any x value and any y value. So anytime you've got an equation of a straight line, you're just going to have x is an element of real numbers, y is an element of real numbers, and you're done. Nice and easy. If it's a quadratic, well, that depends. Right? Let's go and have a quick look at a quadratic. So let's say f of x equals, our basic one is just x squared, like that. And we can see that it's going to keep going out and out and out and out to either side, continuing forever. We can put in any x value and get a y value into this function. But we can't have any y value. We can't have anything that's below that x-axis, right? The graph doesn't exist there. If we had a quadratic, say, that was shifted down a little bit, like this one that I've just done here, now I see I can't have anything that's below a range below -2. Okay, so you have to kind of think about the shape, and Desmos is going to help us by allowing us to graph it and see it. So when you've got a quadratic, our domain is all real numbers, and the range depends on the direction of opening and the vertex, right, where those things are. So let's have a look at a couple examples here. Let's look at this one first. So here's a quadratic, 2 times x minus 1 squared plus 5. Now, based on the information in there, I can tell a little bit about it, but I want to jump in on that tomorrow. Today, we just want to graph it and see what it looks like. So 2x minus 1 plus 5. Let's do that quadratic right now. So I'm going to go f at x equals 2 times x minus 1 squared plus 5. Oh, and I got to fix my brackets there. Pardon me. There we go. Okay, so you say, where is it? Well, let's zoom out. Oh, there it is. Way up here. Way up here. So it looks like that 2 out front has stretched it out and made it kind of skinny. The 1 inside the brackets has moved it over, 1 to the right, and that plus 5 has moved it up 5. So again, we're gonna do more of this tomorrow. Today I just want us to look at it and try and figure out the domain and range. So the domain could be anything. The x values, it's going to keep spreading out in either direction. The x values could be anything. The range, though, the y values we can have, anything above 5 and including 5 is good. That will be on our graph. But nothing below. The graph doesn't exist there. So let's go back to our equation here. Now that we know what it looks like, we'll say, okay, the domain x is an element of real numbers, and we're done with the domain. Could be anything. And you can try plugging anything you want into your equation as an x value, and you will get a corresponding output. For a range, we say, okay, y is an element of real numbers, because it's not just points, but y has got to be equal to or greater than 5. Can't be anything less than that because the graph doesn't exist there. Let's have a look at our other one. This one we're going to try and graph. I notice it's got a -5, so I bet that means it's moved down 5 from our parent function. And it's got a -4, so I bet that means it's moved to the right 4 spaces. That's not going to really matter for domain and range. But I also see this negative out front. If anyone recalls what that negative out front does, throw it in the chat right now. If anyone knows what that negative out front does, throw it in the chat right now. You might not, and that's totally fine. But if you do know, go ahead and throw it in the chat right now. I'm going to start fixing my function here. So Marsh, you said it opens down instead of up. Dash, you said it turns it upside down. So let's get my quadratic here, and let's put that negative in front and see what it does. Here we go. Where did it go? Oh, there it is, right down here. So yep, Paige, you said it flips the graph. Those are all really good ways of describing it. So a negative in front means that it's going to open down instead of up. So in this case, we got one that's opening downwards. So that tells me that our range is going to be anything below and including -5. It could be -5, it could be -6, it could be -1,000,000. But it's got to be anything including and below -5. That's my range. So let's go back again. We'll say, okay, domain is always easy for quadratics. It just could be anything. So domain, x is an element of real numbers. Boom. Range, y is an element of real numbers because it is lines, not points, such that y is less than or equal to -5. Okay, last one I want to show you is a square root function, or a radical function as they're sometimes called. So that's on, there it is. I knew I hit it here somewhere. So a radical equation, those are ones with square roots, right? We call those radicals. We can also do domain and range with this one. And when you did this in Desmos yesterday, you would have seen what the parent function looks like. Would have started at 0 and then gone off to the right into quadrant 1 in kind of a curved shape. So let's try this one in Desmos and see what it looks like. So we'll say f at x, f at x equals, and on my keyboard down here I'll throw the square root symbol. And if I just keep writing, it's going to keep it all under the square root. If I push my cursor button to the right, it'll scoot it out and assume it's not in there anymore. So x plus 1, plus 1. And here it is. That's what it looks like. I think it was plus 1, wasn't it? Plus 3, sorry, plus 3. Let's fix that. Plus 3. There we are. Okay, so when I look at this and I say, okay, domain and range, it looks to me like for my range, it can't exist down below the x-axis. So my range has to be anything above and including 0. It can go up, it can't go down. For my domain, my x values, it looks to me like there's nothing to the left of -3. There's nothing to the left of -3. But anything to the right of -3 is good. Anything to the right of -3. If I keep going that direction, I can see it goes on forever. So for my domain and for my range, let's do our domain first. I'm going to say x is, curly bracket, x is an element of real numbers, such that x is greater than or equal to -3. You can have any x value, but it's got to be -3 or bigger. Nothing lower than that would work. For my range, y is an element of real numbers, such that y is greater than or equal to 0. Can't be below 0. It can't be in the negatives. It can't have negative y values. So if I get something funny looking like this, I graph it on Desmos, I have a look, and then I'm able to figure out the domain and range by having a look at it there. I did make a Kahoot to go through, but I think we'll do that tomorrow because that'll give us something to kind of like reinforce what we've done today. I think I'd like to just show you the homework stuff for today and have you get a jump start on that. So I'm going to jump there next. If you've got any questions about this stuff, of course, you can raise a hand or just post it in the chat. I'm going to stop recording the video right now.